All right, folks. So in section 1.4 of our notes, we're going to be talking all about quadratic equations. As we've seen in previous courses, there are lots of different ways you can solve quadratic equations. We can factor, we can use square roots, we can complete the square, and we can use quadratic formula. We're going to basically talk about all of those in today's notes, as well as when we would use one versus the other. We're going to start with solving by factoring. A couple things we need to know before we start to talk about that. First is we need to make sure that anytime we're solving a quadratic equation that it's in what's called general or standard form. What that looks like is ax squared plus bx plus c equals 0. So you must have one side of your equation equal to 0 in order to solve using most of these methods. The other thing we're going to use when factoring is what's called the zero factor or zero product property. Here is basically what that says. If you have a times b equals 0, then either a equals 0 or b equals 0. In other words, once you have a product, you set each of the two terms that you are multiplying equal to 0 in order to find the solutions. So, like I've already mentioned, when we are solving by factoring, it's important to make sure that our equation is written in its general form first. Let's go ahead and take a look at a few examples of this. For the first example, we've got 2x squared plus 9x plus 7 is equal to 3. So first thing we need to do in order to get this into its general form is we need to subtract 3 from both sides of our equation to give us 2x squared plus 9x plus 4 is equal to 0. Next is time to solve by factoring. Because we have a leading coefficient greater than 1, we're going to have to multiply that by our c value. So 2 multiplied by 4 is 8. Then we need numbers that multiply to be 8 that also add to be 9. Those two numbers are going to be 1 and 8. So I'm going to use those two numbers to split the middle of my expression. So 2x squared plus 1x plus 8x plus 4 is going to be equal to 0. I'm going to then go ahead and factor out my common factors from both. So for my first group of terms, I'm going to factor out an x. It's going to leave me with 2x plus 1. For my second group of terms, I'm going to be factoring out a 4. Also is going to leave me with 2x plus 1 inside the parentheses. And then there's going to be my new greatest common factor. So I'll factor out that 2x plus 1. And then I'll have x plus 4, and my other factor is equal to 0. So in order to solve, we're simply going to take each of our factors and set them equal to 0. So when I set 2x plus 1 equal to 0, I'm going to start by subtracting 1 from both sides, then divide both sides of my equation by 2 to find out that x is equal to negative 1/2. Then doing the same thing with my other factor, I'll set x plus 4 equal to 0, subtract 4 from both sides, and I'll find out that x is equal to negative 4. All right, let's go and take a look at another example of this. On the next example, we've got 6x squared minus 3x equals 0. It's already equal to 0, so I can go straight to factoring this. And in order to factor, I'm going to first take out a greatest common factor. In fact, that's really all we have to do here. Then I'm going to set each of my factors equal to 0 and solve them. For the first one, I'll divide by 3 on both sides and find out that x equals 0. For the second, I'll go ahead and set 2x minus 1 equal to 0. Add 1 to both sides will give me 2x equals 1. Divide by 2 on both sides, and I found out that x is equal to 1/2. Let's look at one more example of solving by factoring, and then we'll move on to our next method. So in this last example, similar to our first example, we need to start by getting this into its general or standard form first. That requires us to add 8 to both sides. So we'll have 3x squared plus 10x plus 8 is equal to 0. Once again, we have a leading coefficient that's different from 1, so we'll take that and multiply by our constant. 3 multiplied by 8 is 24, and then I need numbers that multiply to be 24 and add to be 10. Those numbers are going to have to be 4 and 6, so I'll use those to split my middle term into 2. And then now I can go ahead and factor by grouping. For my first group of terms, I've got a greatest common factor of x, leaving me with 3x plus 4 in the parentheses. For my second group of terms, I have a leading coefficient of 2, also leaving me with 3x plus 4 in the parentheses. So now 3x plus 4 is going to be my greatest common factor. The remaining parts, x and 2, are going to become my second factor. And then now I should be ready to set each of those factors equal to 0 to find out my two solutions. For my first term, or for my first factor rather, 3x plus 4 equals 0. We subtract 4 is 3x equals negative 4. Divide by 3 when we find out one of our solutions is x equals negative 4/3. The second factor is just one step. We subtract 2 from both sides, and we find out that x is equal to negative 2. So solving by factoring is as simple as making sure your equation is in standard form. going ahead and factoring, and then setting your factors equal to 0. Next, let's go ahead and take a look at our second method for solving quadratic equations, which is what's known as square roots. So square roots is going to be the method that we will use anytime we do not have a middle term. And this is one of the two methods where you do not need to have your equation in its general form first. So for example, I've got 4x squared equals 12. I'm going to solve this directly for x by dividing by 4 on both sides to find out that x squared is equal to 3. Then taking my square root on both sides in order to cancel out my power of 2, I'm going to end up with x by itself is equal to, I need to make sure I include plus and minus since technically it's the absolute value of x. And then I'll take the square root of 3, which does not simplify. So my solutions for this first example would be that x is equal to both positive radical 3 and negative radical 3. On my second example here for solving by square roots, even though it's a quantity being squared, I can still take the square root. Now, if there was anything else outside of that quantity being squared, then I would obviously need to get rid of that first. Here, since I just have it as that quantity squared, I can go directly to taking the square root of both sides. Once again, remembering that I need to make sure there's a plus and minus in front of my radical 7. And then in order to get x by itself, it's one more step. We add 3 on both sides to find out that x is equal to 3 plus and minus the square root of 7. So my two solutions for this equation are both 3 plus radical 7 and 3 minus radical 7. Let's go ahead and look at our next method as well, which is related to square roots. In fact, we will use square roots in this next method. It is what is called completing the square. So first of all, when would we choose to use completing the square versus other methods? Well, one would be that it's not a factorable equation. If it's factorable, that is our preferred method. It's usually the quickest and most efficient method. The other thing is going to be that we will now have a middle term. So unlike those previous two examples where we did not have a linear term with just x in it, we're not going to simply be able to take the square root of both sides of our equation. Now, preferably, we would like for that middle term to be an even coefficient, so a plus 2x, a minus 6x, and so on. But we don't necessarily have to do that if we need to, and we can always use fractions. So let's go ahead and talk through this method with a few examples to see what this is all about. For our first example, if we have x squared minus 6x plus 2, then similar to square roots, I'm going to get rid of any constants from one side of the equation. In other words, I'm going to subtract 2 from both sides to leave me with x squared minus 6x on the left side is equal to a negative 2 on the right side. So similar to solving by square roots, I don't need my equation to be in standard form. In fact, I don't want it to be in standard form when I'm solving by completing the square. So here's how we're going to set up completing the square. By completing the square, it means that we want to essentially factor this so that my factors are the exact same. And so I'm going to go ahead and set up our two factors here. Since it's minus 6x, they're both going to be minus. And then simply I need to take the middle term and divide it by 2. In other words, take negative 6 divided by 2 is negative 3. Those are then going to be my two factors. Now here's the idea. If it's the same factor written twice, I can simply rewrite it as that factor being squared. Now in order for this to work, I can't just pull these numbers out of thin air. The x squared is taken care of when I take x multiplied by x. The minus 6x is taken care of when I take negative 3x and negative 3x and add them together. What I'm missing is my constant term, and that constant term is found by taking negative 3 times negative 3, which multiplies to be positive 9. So what I'm going to do in order to factor it the way that I did is I'm going to add by 9 on the left side of my equation. Now this is an equation, so if I add by 9 on the left side, I also need to be careful and make sure I'm also adding by 9 on the right side. And then when I simplify that right side of the equation, negative 2 plus 9 is equal to 7. I end up with a similar equation to the one we just solved by taking the square roots. And so in order to solve this equation, once again, I'm going to take the square root of both sides of my equation. I'm going to end up with x minus 3 being equal to plus and minus the square root of 7. And then to get x by itself, it's one more step. I'm going to add by 3 on both sides of my equation to find out that x is equal to 3 plus and minus radical 7. Let's go ahead and take a look at a couple more examples of this method. For our next example, we have x squared plus 4x minus 32 equals 0. So similar to our last example, we want to add any constant terms over to the other side. That will leave me with x squared plus 4x on the left side is equal to 32 on the right side. So once again, my goal here would be to factor this so that my factors are the exact same. In order to do that, I'm going to take half of my middle term, which is a positive 4, to find out that x plus 2 is going to be my repeated factor. And so knowing that, I can now write that as x plus 2, that quantity squared. And then once again, to figure out what number I would need to be adding by, I simply multiply my constants together. 2 multiplied by 2 is 4, so I'm going to add by 4 on both sides of my equation. On the right side then, simplifying, 32 plus 4 is 36. And now I'm ready to solve this by square root. So take the square root of both sides of the equation. X plus 2 is equal to plus or minus the square root of 36, which is 6. And then to get x by itself, I subtract by 2 on both sides. And I find out that x is equal to positive or negative 6 minus 2. Now in this case, we're able to simplify just a little bit further. I can separate this into its two numbers. If I take positive 6 minus 2, that's 4. If I take negative 6 minus 2, that's negative 8. There would be my solutions to this equation. Okay, let's go ahead and see one more example. Let's see what happens when we have a number in front of x squared. The easiest thing typically to do is to divide by that number across my entire equation. So if I have a 9 in front of x squared, I'm going to go through and divide everything in my equation by 9. That's going to give me x squared minus 4/3 x is equal to 14/9. And then moving on to my next step, I want to factor this so that it's the same factor written twice. I'll go ahead and copy down x and the minus sign, and then taking half of 4/3, that's going to be 2/3. And then to figure out what number I would need to be adding in order for that to work, take negative 2/3 times negative 2/3 is a positive 4/9. So I'm going to add by 4/9 on both sides of my equation. So on the right side then, 14 plus 4 is 18/9. And then 18/9 I can reduce and say that that's the same as just positive 2. Simplifying this just a little bit, since it's x minus 2/3 written twice on the right side, I can rewrite that as x minus 2/3 squared is equal to that positive 2 on the right side. Then to solve this, I will simply take the square root of both sides of my equation. That will leave me with x minus 2/3 is equal to plus and minus the square root of 2, leaving me with one final step here to get x by itself, which is that I add by 2/3 on both sides of my equation, and then that will leave me with x being equal to a positive 2/3 plus and minus the square root of 2. All right, it's time for our fourth and final method for solving quadratic equations, and this is one we've actually seen before back in section 1.3. This is going to be using that quadratic formula that we had discussed before. As a friendly reminder, this is a formula that you are expected to know. That formula is that x is equal to the opposite of b plus and minus the square root of b squared minus 4ac all over 2a. One thing we have not talked about previously is this idea of what's called the discriminant. The discriminant is simply the part of the quadratic equation which is under the radical sign. So discriminant is equal to b squared minus 4ac. The discriminant is useful in determining the number and type of the solutions for an equation. If the discriminant is a positive number, then you end up with two real solutions, neither of which is a complex number. If the discriminant is equal to 0, you end up with one real solution. We do, however, say that it has a multiplicity of 2, and we'll talk more about multiplicities later on. Essentially what that means is that that same solution is happening twice in the same equation. And in the third scenario, if our discriminant is a negative number, then what we say is that that equation has no real solutions. However, what that does mean is that it does have two complex solutions. So we're going to take a look at a couple of examples using the quadratic formula here on the next page. The first example is x squared plus 3x equals 9. One thing about quadratic formula is that it does require for your equations to be in standard form or general form, meaning we would need to start solving this equation by subtracting 9 from both sides. And then our coefficients become the numbers that we plug into the formula. So A is 1, B is 3, and C is negative 9. Plugging those in, we get negative 3 plus and minus the square root of 3 squared minus 4 multiplied by 1 multiplied by 9. All of this over 2 multiplied by 1. Simplifying what's under the radical, we'll go ahead and take 3 squared, which is 9, minus 4 times 1 times 9 is 36. 9 minus 36 leaves us with negative 27 under the radical, and 2 multiplied by 1 underneath. The fraction is 2. To simplify this square root of negative 27, first let's rewrite it using a perfect square. The largest perfect square we can divide it by is 9. And then we'll take 9 times 3 times negative 1 in order to keep it the same. The square root of 9 being 3, the square root of 3 being unable to simplify, and the square root of negative 1 reducing to be I. So then here is what our answer begins to look like. Negative 3 plus and minus 3 radical 3I all over 2. Now, since our final answer is a complex number, we then need to go ahead and separate that so that it's written in its standard form, A plus BI. So we'll rewrite it as negative 3 over 2 plus and minus 3 radical 3 over 2 multiplied by I. Let's take a look at just one more example using the quadratic formula, and then we'll see how we can apply these in some real-world context. In this next example, once again, we need to make sure that our equation is in its general or standard form, meaning we're going to subtract 7 from both sides of our equation. Once we've done that, we can go ahead and identify our constants, or our coefficients rather, A, B, and C, and then plugging those into our quadratic equation, we end up with negative 4 plus and minus the square root of 4 squared minus 4 multiplied by negative 7 all over 2 multiplied by 4. Simplifying this, we end up with negative 4 plus and minus the square root of, I'll go ahead and use a calculator for this part, so I'll go ahead and take 4 squared minus 4 multiplied by negative 7 to figure out that the number underneath my radical sign this time is 128. And then simplifying my denominator of my fraction, 2 multiplied by 4 is going to give me 8. Let's go ahead and reduce the square root of 128. The largest perfect square you can divide that by is 64. 64 times 2 is 128. And then the square root of 64 reduces to be 8. So 8 radical 2 is how we will simplify our radical. So replacing that in our current expression, we end up with negative 4 plus and minus 8 square root of 2 over 8. And looking at all of the numbers here outside radicals, 4, 8, and 8 are all divisible by 4. So to reduce this, we'll divide them all by 4 to end up with negative 1 plus and minus 2 radical 2 all over 2. Now in this case, because there's not a complex number I in this, we do not need to separate it into 2 terms. However, if we would like to, we can go ahead and do that by rewriting both of my terms in the numerator over 2. In other words, negative 1/2 plus and minus 2 radical 2 over 2, at which point we can actually simplify that second fraction. If I have 2 radical 2 over 2, then my 2's outside the radical can divide to be 1. Leave me with this as another potential answer, which is equivalent, which is negative 1/2 plus and minus the square root of 2. For our last part of today's notes, we're going to take a look at how we can use quadratic equations in some context. So in this context, and in many contexts, quadratic equations will often occur in problems which deal with area. So for an example, let's say we have a bedroom which is 3 feet longer than it is wide, which has an area of 154 square feet, and we want to find what the dimensions of the room are. I'm going to go ahead and draw a diagram here just to give us an idea of what's going on. I've got a bedroom with a width which is unknown, and then I also have a length which is unknown. However, I do know that the length is just 3 feet longer than the width, and so instead of creating a new variable, I'll go ahead and continue to use the same variable that I had before, and then simply add 3 to it. In other words, my length would be the same as my width plus 3, or w plus 3 for the variables I've chosen. And then if I know that it has an area of 154 square feet, then I'm going to go ahead and multiply my length by my width. In other words, I'm going to take w and multiply that by w plus 3, and know that that has to be equal to 154 square feet. In order to solve this equation, what I'll first do is distribute on the left side of my equation to end up with w squared plus 3w being equal to 154. Then in order to get this into its standard form, assuming that that's what I will need to solve it, I'll go ahead and subtract 154 on both sides to find out that w squared plus 3w minus 154 is going to be equal to 0. Now, in order to solve this, I've got different methods that I can use in order of which ones I use. And remember, the order that we've seen them in is typically the order that we try to solve them in. We will first try to factor. Second would be solving by square roots when possible. Third would be using completing the square. And as a last resort, we can solve any quadratic equation we'd want to using the quadratic formula. So first, let's see if we can maybe factor this equation. We're looking for numbers then that multiply to be negative 154 that would also add to be 3. So let's go ahead and try some different numbers here, dividing negative 154, knowing that the numbers are going to have to be close together. I might start by trying to divide by 12, which does not work. So maybe next I try dividing by 11, which also does work now. In fact, if you look, 11 and negative 14, while they would add to be negative 3, switching the signs would actually give me positive 3. In other words, I can go ahead and factor this to be w plus 14 multiplied by w minus 11. And then using my zero product property, I can set those both equal to 0. So w plus 14 equals 0 will lead me to one solution, which in this case will not make sense in context. It is not possible to have a width of negative 14 feet, so we can simply ignore that solution. Instead, we'll look at our other factor where w minus 11 must also be set equal to 0, leading us to an answer which is much more reasonable, which is that our width is 11 feet. So we were asked at the end of this problem to find the dimensions of the room. So we can now say that the room has a width of 11 feet and a length of 14 feet. If you're wondering where I got that length from, remember that the length was 3 more than the width. In other words, w plus 3. And if you take 11 plus 3, that does give you 14. And then there would be your dimensions. All right, guys, that's all we've got for today. Until next time, have a good rest of your day.